screen is visible?
Visible, sir. Can you see sir?
Okay. No. I want to just to test it. That's all.
Okay, sir.
1 minute. Just 1 second. Can I go for full screen or not? Let me check.
Full screen, sir. It is visible, sir.
Okay, that just 1 second.
5 minutes, sir.
I want to check the change in the slide. Just 1 second.
Okay, sir. Okay.
Can I know there is a change in slide?
So it is a big screen you are asking, sir?
No. The slide is changed or not? Slides are changing?
Changing, sir. Changing.
Okay,
Coming
okay.
one by one, sir.
Okay. So now it is everything is changing, right?
Okay, sir. No problem. You are seeing it, sir. Good evening, all. We are delighted to welcome you to the fifth day of our 5-day international webinar. I am thrilled to delve deeper into our topic with you today.
I'm Dr. K. Nirmala Jyoti. I invite Sister Rabita and Sister Bhavya to come and sing a song.
They shall be showers of blessing. This is the promise of love. They shall be seasons refreshing, sent from the Savior above. Showers of blessing, showers of blessing feeding. Mercy drops on us are falling, but for the showers we plead. There shall be showers of blessing, send them upon us, O Lord. Grant to us now a refreshing, come and honor thy word. Showers of blessing, showers of blessing we need. Mercy drops round us are falling, but for the showers we plead. There shall be showers of blessing, oh that today they might fall. Now as to God we are confessing, now as on Jesus we call. Showers of blessing, showers of blessings we need. Mercy drops round us are falling, but for the showers we plead. But for the showers we plead. Heavenly Father, we come to you today asking for your guidance, wisdom and support as we begin this meeting. We thank you, dear God, you have showered us with so much blessings, and your presence continuously reminds us of your faithfulness and guidance. May we humbly ask you the grace to shower upon our resource person who is going to share the most of his knowledge for the respective topics. May all the participants absorb the invaluable knowledge, experiences, and put it into practice, whatever they learn. We make this prayer through Christ our Lord. Amen.
Thank you, Sister Rabita, Sister Sureka, and Sister Bhavya for the inspiring and heartfelt praise song. Your presence and contribution have added a meaningful touch to this gathering. I am delighted to offer a warm welcome to each of you for this webinar. We hope it proves to be both thought-provoking and engaging. Significance of the day. It is focusing on innovative approaches in green chemistry for addressing emerging challenges in chemical and allied sciences, lies in its relevance to both scientific advancement and environmental sustainability. Green chemistry is at the forefront of transforming chemical processes to to reduce harmful environmental impacts, promote sustainability, and conserve resources. This test serves as an opportunity to highlight the role of innovation from reducing hazardous waste to developing eco-friendly materials. Its sad and global concerns encourage the interdisciplinary collaboration and educate and inspire. It aims to inspire scientists, researchers, and students to embrace greener, more sustainable practices in their work, contributing to a cleaner and safer future. I would like to welcome Dr. V. Sumulata, co-convener of the webinar, to introduce our distinguished speaker.
Good afternoon, everyone. It is my great pleasure to introduce today's speaker, Dr. Ratnakaram Venkatnath, a highly distinguished academic, researcher, and educator currently serving as Professor of Chemistry at the School of Science, Geetham, Dept University, Bangalore. With over 26 years of experience, Dr. Venkatnath has made significant contribution to the field of chemistry and biotechnology have been profound, both in academia and research. Dr. Venkatnath holds an impressive array of academic qualifications, including a PhD in chemistry from Nagarjuna University, along with PG diploma in biotechnology and MPhil in biotechnology. His leadership roles have been equally noteworthy. Over the years, he has supervised the successful completion of 12 PhDs and 4 MPhils theses, authored 101 research papers, contributed to 9 book chapters, and authored 4 books. Additionally, he has filed 2 patents in innovative areas of chemistry and product development. In his tenure as head of the Department of Chemistry at Geetham University from 2016 to 2021, Dr. Venkatnath led both academic and administrative initiatives that significantly contributed to the growth of chemistry. Currently, he serves as co-chair of Board of Studies in Chemistry at Geetham University, where his expertise continues to influence the academic direction of the institution. Dr. Venkatnath's research acumen is exemplified by several major funded projects, including partnership with both the industry and government agencies. He has secured rupees 52.61 lakhs of industry-sponsored research along with funding from DST SERB, Inspire and the UGC amounting to over rupees 198 lakhs for projects aimed at advancing chemical sciences and sustainable technology. Beyond his academic achievements, Dr. Venkatnath has been recognized with numerous awards, including the Best Researcher Award from Geetham University, the Adarsh Vidya Saraswati Rashtriya Puraskar for Best Teacher, and multiple accolades for his excellence in teaching and research. His leadership in academic administration extends to his roles as Director of Admissions at Geetham and Vignan's University, where, where he oversaw admissions for diploma, UG, PG, and PhD programs. Dr. Venkatnath's commitment to the scientific community is evident from his membership in esteemed professional bodies, including the Indian Chemistry Society and the Indian Science Congress Association. He had been a member of numerous editorial and reviewer boards for international journals, contributing to the dissemination of knowledge in chemistry and biotechnology. A renowned speaker and mentor, Dr. Venkatnath has delivered over 41 invited lectures at seminars and conferences, inspiring young scholars and advancing science discourse. His pioneering research and teaching continue to shape the next generation of chemists and biotechnologists. Staff's extensive expertise and commitment to advancing knowledge in their field will undoubtedly inspire and contribute to future innovations and academic growth. Now, we are honored to welcome Dr. Ratnakaram Venkatnath sir to continue the session. Thank you. Thank you.
Sir, we respectfully invite you to begin your session on Artificial Intelligence and Internet of Things post Green Chemistry. Thank you, sir. We are grateful for the opportunity to gain such valuable insights and are inspired by the possibilities that AI and IoT present. Thank you, sir. Not audible, sir. Sir, you are in mute, sir. Please unmute. Please unmute, sir.
Sorry.
Okay.
Am I audible?
Yes, yes.
Oh, okay. I'm so thankful to Dr. Nirmala and the principal and other administrators of JMJ College for giving me an opportunity to interact with the all participants. Today, I'm going to have a little bit discussion how the green chemistry is augmented by the new technologies like artificial intelligence, machine learning, and IoT, Internet of Things. So already for the last 4 days, many speakers, I think they continuously discussing about green chemistry. Green chemistry is having a set of principles where either we can reduce or we can eliminate what's called hazardous materials, or we are going to design and manufacture and application of the new chemical products. That was already discussed by the previous speakers. If you look at the main 12 principles of green chemistry, we can already, you are aware that. Just have a look, because whenever I am going to discuss in the case of either AI or ML or IoT, okay, which principle is going to be suited there, you must be able to map yourself. That's why. Okay, so it may be prevention of waste, or it may be atom economy, and third one is less hazardous chemicals synthesis, and the fourth one is synthesis of safer chemicals, fifth one is the safer solvent, sixth one is the design for energy efficiency, and the seventh one is use of renewable stock, and the eighth one is the reducible to reduce the derivatives, and the ninth one is using of the catalyst, and then 10th one is the design for the degradation, and the 11th one is real-time pollution prevention, and the 12th one is safer chemicals for accident prevention. So this is about the 12 principles. I hope that already you are well aware of this. That's why I'm going to discuss about how we are going to achieve this in the case of new technologies. This is the one which is nothing but QBD. Here you can see that this is a QBD. There is a quality by design. Quality by design is the one of the technique nowadays everyone is using, how it can be used to reduce the uses of the chemicals, the two hazardous chemicals and the quantity of the chemicals, and the runtime in any HPLC or GC can HPLC or in the case of GC also the gas can be reduced, and we are able to get a sustainable robust analysis where this QBD, that is quality by design, is useful to achieve 3 R's, either reduce, replace, or recycle. And I'm not going to much discuss about QBD, that is quality by design. Last in my few lectures, repeatedly I was discussing about the application of the QBD, how it can be used in the case of analytical chemistry. Now I'm going for a new one. If you look at industry, at present we are in the industry 4.0 era. So if you look at a shift, industry 1.0 to 2.0, 3.0 and 4.0, we are aware that industry 1.0 mainly depends on the usage of the steam, water and power and mechanization was started. Whereas in the case of the industry 2.0, electrical power was useful for the mass production. Whereas the industry 3.0, where automation we were able to observe with the involvement of the robotics and inclusion of the IT systems. Now at present we are in the industry 4.0, where we are able to witness the smart factory with the usage of the advanced techniques. It may be artificial intelligence, or it may be big data, or nothing but the data science and IoT, Internet of Things, like that. So when we look at the industry 4.0, the flow of the process for green manufacturing can be seen here. So in the case of industry 4.0, the main aspects here, as we have seen already, it may be IoT, as I said, that Internet of Things, or IIoT. What is the difference between IoT and IIoT? Means Internet of Things. First of all, here the name itself indicates that Internet of Things. Things means physical things. So if you are able to manipulate or handle a physical system or physical thing with the help of the internet, we call that one as IoT. So for example, if you want to switch on or switch off the air conditioning system in your house, but you are located at your working place, so how are you able to do that one? So the air condition is a physical system. You are able to manipulate. That is, what is the manipulation? Either stopping or switch on or switch off. You are able to do with the help of the internet. So by using your mobile, by sitting in your office, you are able to switch on or switch off the air condition. Means a physical system was able to manipulate with the help of the internet. So that is one example, air condition. In a similar way, in the case of industry or in our chemical laboratories, if any instrument, if you are able to manipulate, that is a thing, and with the help of the internet, that is called IoT, Internet of Things. IIoT means double I. What is that? Industrial IoT. Means how IoT can be used for the industry. When we take this IoT, it is having a wide number of applications. Whatever I discussed, manipulation of air conditioning in your house, that is a social application. And that one is having medical application, pharmaceutical applications, industrial applications. So if you use IoT in industry, that is called IIoT. So whether you use IoT in industry or out of the industry also, for the purpose or prosperity of the IoT in industry, then automatically we require the cloud data. Means a large amount of the pool amount of the data will be available. That too, the availability will be in the cloud, where accessing can be done from many physical points. Of course, in this case, as we are discussing about industry, there will be involvement of energy, which is also associated with waste. The waste, it may be in terms of energy or it may be in terms of the mass. Here, so this is about the basic things of industry 4.0 aspects. When we look at the process integration, we have to look into always the real-time manipulation. What is the meaning of real-time manipulation? For example, if there is a leakage of a particular solvent from a tanker, so immediately sensing is required, and if possible, auto stopping is required. So that is called real-time application. So if such real-time application is possible, such a factory is called a smart factory. Of course, in this case, not only the complete overtake by the instruments, even the human beings also will be involved. So there will be both working of machines, either independently or at the interface of the human and the machine will be observed. And as far as the outcomes in terms of our green manufacturing technology are, number one, here you can get economic products. Means waste is reduced, so automatically the profit increases, so economic products will be there. And then safety means if there is any leakage of any chemical, or if there is any fire, so immediately the concerned sensor will be acting. So in the case of IoT, it means what? You are able to manipulate the instrument with the help of ultimately a sensor. The sensor may be a thermal sensor, or thermal sensor means if the temperature change is there, or it may be a chemical sensor. Okay, so in this way we are able to achieve the safety, hence the health of the workers as well as the health of the population surrounding the industry and at large on the globe can be monitored, and we are able to protect the environment. So when we take this industry 4.0, at present this is in progress, and then as we discussed that smart systems along with the complete automation are existing, which is aided by Internet of Things, artificial intelligence, big data, cloud computing, VR, 3D printing, etc. And the main focus of this industry 4.0 is sustainability or sustainable development. Already we are aware what is the meaning of the sustainable development. The sustainable development is a development where the utilization of the natural resources happen in such a way we are able to hand over the same natural resources for the future generations. So that is called sustainable development, that is already known for all of us. As we said, in the case of industry 4.0, as we are using IoT, Internet of Things, here there will be involvement of cyber physical systems. What are cyber physical systems? In our simple language, being a chemistry person, we can say nothing but sensors. So here the cyber physical systems here we are using are nothing but the sensors which are able to sense either physical parameter or chemical parameter, sometimes it may be biological parameter, and it is going to transfer the information through internet. That's why we call this one with a broad word cyber physical system. So this cyber physical system in our simple language nothing but the sensors. These sensors are useful for not only for the production of the chemicals, even for their logistics they are going to be useful. And here if we are able to do, then we can declare ourselves that there is involvement of digital transformation. And here in this case we can say intelligent manufacturing or digitalization is existing. When we take this industry 4.0, as we said, AI, IoT, cybersecurity, simulation, blockchain, cloud computing, human-machine interface, machine learning, autonomous robots, additive manufacturing, all these different segments are there in which we are going to discuss at present only the first two, that is AI, a little bit ML, and a little bit about IoT. So let us start with IoT, Internet of Things. Let me repeat. In the case of IoT, things means the physical things. Means it may be an instrument or it may be an equipment which you are able to operate with the help of the internet. We call Internet of Things. What is the significance of this IoT in the present era? We can say that in the case of industries, by 2020, 50 billion devices already they are connected. Means we are able to operate them remotely without our physical presence at that particular instrument. Keeping yourself away from that, you can operate them. And it is an expectation that almost 80% of the companies all over the world, they are going to utilize IoT for digitalization of their firms by the year 2025. So, what is IoT is doing? It is able to make a network between three things. One is machine, and who is operating? Human, with the help of internet. So IoT is able to make an internet, a network between machine, human being, and internet. When we take this IoT, as I said, there are so many other related words are there. One of that one is IIoT, that is industrial IoT. What is this industrial IoT? In the case of industry, ultimately our aim is the processing, so that we are able to get a product. So it is industrial IoT connects process, product, and the labor, nothing but the people. And one more is there, that is IoT PM. What is that? Internet of Things for PM. P means pharmaceutical, M means manufacturing. And then there is one more word, IOPT, that is Internet of Pharmaceutical Things. Likewise, there are so many related words are there. Now, whenever we take, whether it is IoT, IIoT, IoT PM, IOPT, and of course afterwards we are going to use one more word, IOCT, Internet of Chemical Things. IOPT gone. Now we are going to discuss afterwards IOCT, that is Internet of Chemical Things also. In all areas, we are going to operate some physical things. What are the physical things? Some of them are listed here. So, in the industry, what are the physical things a chemist or a particular worker is going to operate? Pressure gauge, pH probe, air compressor, sterilizer, heat exchanger, multimedia filters, vacuum pumps. Likewise, we can say that there are so many physical things which can be operated by us in any industry. As we said, IoT is a broad one, and which we can say the subsets are IOMT, that is Internet of Medical Things. Further subset is IOPT, Internet of Pharmaceutical Things. Likewise, we can discuss a lot. Okay. Here, in the previous case, already I said that the things are the list given here: pressure gauges, pH probes, sterilizer, etc., etc. Whereas, in a broad way, the things can be designated as all of whatever we discussed earlier, all of them, they come under the second category, sensors. They may be sensors. They may be RFID tags. What are RFID tags? Radio frequency identification tags. Or they may be actuators, or it may be mobile phones, etc. So, the things may be, earlier we said only sensors, it may be actuator, mobile phone, RFID, all of them here we can define under a broad term of things. Here, in the case of IoT, as we said that there will be a physical thing that is connected with the internet and the people. For this purpose, we require some conjunctions. What are those conjunctions? Means MEMS, that is micro electromechanical systems, or it may be wireless technologies, that is microservices, internet, all these are required. When we take this IoT, it is showing its effect in all over the fields. As I said, nowadays we are able to operate, that is switch on or switch off the air condition in your house simply by sitting in your office. That is called social IoT. I said that if you are using IoT in the industry, we call IIoT. And similarly in the pharmaceutical industry, medical industry, whatnot, in almost all sectors they are going to be useful, including different subsectors of pharmaceutical. It may be manufacturing or discovery of the drugs, means R&D division, or for the remote monitoring of the patient. So if a patient is with a thing in his heart, and what is his pulse rate, that can be monitored from other place, and similarly individualized medicine, etc., etc.
Sir, any problem, sir?
It's working, sir. Okay.
Okay. Just one second. So, in the case of usage of IoT in one of the pharmaceutical manufacturing unit, let's take as an example, so that we can understand any other chemical industry, how it is going to be useful. The first application is nothing but the predictive maintenance. The first application is
Okay.
predictive maintenance. What is the meaning of the predictive maintenance? What in the case of any industry?
Validatory, we are going to close in Jutumani. Water tanks, principal address ఉంటుంది.
సరే
అమ్మాయి రిపోర్ట్ కట్టాలి. రిపోర్ట్ ఇవ్వాలి ఆవిడ రాస్తుందో లేదో.
ఎక్స్క్యూజ్ మీ సార్.
నేను ఉంటాను, రిపోర్ట్ చదవాలి ఆవిడ. అడుగు, రిపోర్ట్ చదవాలి, నువ్వు రాసారా లేదని అడుగు. ఈ 5 days రిపోర్ట్ చదవాలి మేడం, వ్యాలిడిటీలో. మరి అవన్నీ మర్చిపోయింది ఆవిడ. లేదు, డైలీ దీనికి వెళ్తున్నారు. అంతే నువ్వు కూడా ఎక్కువ ఎంటర్టైన్ చేయదు. ఇదేదో అయిపోతే ఇంకా వాళ్ళకి సర్టిఫికేట్ అందకపోతే గొడవ చేస్తారు. సర్టిఫికేట్ అందడం చూసుకో. డిసైన్ చేశారు సర్టిఫికేట్. నేను మర్చిపోయి దాని గురించి. ఆన్లైన్ ఇచ్చటమే, అది గొడవ చేస్తారుగా. ఇప్పుడే ఇవ్వాలి, రేపు నుంచి అడుగుతారు సర్టిఫికేట్. అదే ఆన్లైన్ లేదు మైకు.
Okay, sir. Continue, sir. Continue.
Okay, thank you. So when we take application of IoT in one of the pharmaceutical manufacturing unit, then we can understand how it will be applicable even in other chemical industries. When we take a particular mission, let us say that I have taken a reactor. When we take reactor, sometimes the reactor may fail. So until it fails, okay, we are not in a position to anticipate it, and the entire work will be stopped for a little time. But if we use IoT, that is Internet of Things, then we can anticipate the failure of the mission. Means after how many days or how many hours that particular mission is going to fail. So based on the prediction or anticipation of failure of a particular instrument, we can bring one more reactor in advance, keep ready so that when it fails, immediately you can replace with the new one. So whenever you are able to predict the maintenance, automatically the gap in the manufacturing reduces, and automatically there will be no short of production. And timely decision. What is the timely decision? Here, in the case of IoT, if it is assisted by the machine learning process, where we are going to develop some algorithms, analyze the data gathered, and that one is going to help us to take a particular decision. So Internet of Things is useful for time to time data gathering. Such gathered data is processed by machine learning with a suitable algorithm, so that we can come to a decision on the working of a particular instrument. And connected factory. Connected factory means the complete or total monitoring of the factory, and controlling of the entire factory can be done with the help of this IoT. And here, in this case, as we discussed, one of the main requirement is nothing but real-time logistics. Real-time means immediately you must be able to take a decision. So that one is associated with RFID and sensors. Of course, in addition to that, smart warehousing, safety, supply chain control, all of them also come into consideration. When we take this IoT, how is it going to help us in industries? In the case of industries, first of all, it is going to help us to reduce the cost, and it also helps us to reduce the time required for the manufacturing, and helps to increase the quality of the product. And not only that, the entire size of the industrial plant can be reduced. So whenever we take IoT, this one is useful to design engines to gather the information, and the information is stored, and the stored information is analyzed. So whatever the huge amount of the data is analyzed in this case. And here simply the controlling can be done with the instructions from different inputs, even including the mobiles also can be done. Now, so here the technologies which are involved here, okay, like these are the fundamental things which are already known to all of us. Now, here we are going to discuss some of the methods where we are able to increase the manufacturing efficiency, and what type of IoT solutions are there. Now, let me take one example. The first method, the first one is the method I want to reduce the downtime of the equipment. So my aim is to reduce the downtime of the equipment. Means downtime of the equipment means here I want to see that it will be mostly in operation. What is the IoT solution? The IoT solution is the whole operational data and status, they are gathered, and we must be able to use the smart equipment. And the advantage is, and real-time dynamic scheduling can be done for a shop floor process. Likewise, many examples are there. And when we take the IoT in a chemical industry, for there are many applications are there. First one is predictive maintenance, as already we have discussed that. Okay, at what time a particular machine is going to shut down. So how can we come to know? Means by continuous monitoring the health of the instrument with the help of the sensors which are associated with the particular instrument. And then operational insights. Operational insights means, for example, in the reactor, I want to maintain a particular pH. So, for example, I want to maintain a pH of 4.8. For that, I am going to use either alkaline or acidic buffers. Whenever I use either acidic or alkaline buffers, automatically sometimes a minor increase or a decrease in the pH can happen. So what is my aim of maintaining the pH? But actually, what is the pH maintained? So my aim is different. Actually maintained pH is different. So what are the operational insights? Similarly, temperature. I want to maintain 40 degrees. So whenever I'm going to maintain the 40 degrees, based on the rise or decrease of the temperature, I circulate either hot water or chilled water in the jacket. So ultimately there will be either adjustment of the temperature, but it may vary plus or minus delta X from the expected temperature. So that is operational insight. Quality assurance. Quality assurance means here whenever a product is formed, so the required quality is maintained or not, and then smart products and the connected logistics and the new business models and the environmental sustainability, all these come into the applications of this industrial IoT or IoT in the chemical industry. So already we have seen by 2020 or 2025 what is going to happen. So this IoT, how in the chemical industry, earlier we have seen the general industries. This is in the case of the chemical industries. In 2022, almost $57.35 billion worth of instruments were used, and it is going to increase to $111 billion by 2027. So that itself shows that the growth rate, whatever is going to happen, a very good and remarkable growth is there in the case of utilization of IoT in the chemical industries. And then, so the question arises, what is the driver which is going to force to increase or for the observed or expected growth rate? That is the anticipated, this demand, the increase in the demand is mainly driving the market. And the trends, if you look at the trends, we can see that there are huge technological advancements are there. They are gaining popularity day by day on IoT, and it is going to, this IoT market is going to occupy all over the world. And this is about the business things which you no need to discuss much. Now the question arises, okay, we are saying that IoT in chemical industries, is there any industry which is already working in it? Yes. We can say that Microsoft, starting from Microsoft, BASF, Hitachi, and then Siemens, okay, SAP, we should not say SAP, SAP, and ATOS, etc. So all these industries at present, they are doing a lot of research in it. Now, what we are doing here? So this is a general thing, not related with only chemical system. So if you can see that the IoT, not only in the chemical industry, in all fields, as I said that IoT is having its own role in society, industry, and everywhere. So that's why different fields of the world, wherever you are able to place a sensor, collect the data, and then you are going to store the data in the cloud for easy accessibility, so that and not only that, the transmission of the data can be used so that it can be utilized for our final requirement. It may be for protecting the climate changes, and then food or water quality, what it may be. So where you can see that a wide range of applications are there for IoT. Okay, we have seen how IoT is going to help us in our day-to-day system and industry, pharma industry, etc. Now let's discuss about our laboratories. Means let's take our own college. Let's say that we are having some MSc analytical chemistry education, how it is going to be useful. So let's have one discussion on that. So if not immediately, in future, there are fair chances of integrating the IoT technology with analytical chemistry education. So before Corona, prior to Corona, we never thought that such a lecture will happen. I will be giving a lecture from Bengaluru and you will be listening simply sitting in your class or even our bedroom or somewhere. Now we are able to do it. So similarly, such evolution may happen soon where IoT is going to be integrated with the analytical chemistry education. How it is going to be done? That can be done by leveraging the IoT devices and the sensors. Or before discussing a lot of things, simply let me say that. For example, JMJ college is having some GC, that is a gas chromatography instrument with them. Let us suppose that GC instrument is available with JMJ college with Tenali. Okay, their sister organization is there in Rapala. They are not having the GC. Gas chromatography is not available at assistant college of the JMJ college in Rapala. So the Rapala college students cannot come to the Tenali to operate GC. Then what to do? In future, the GC, the gas chromatography, the sensors and the manipulation, the management, everything can be done from a Rapala Assistant College of JMJ by using their laptop. What is going to happen? Okay, the students will be simply sitting in a Rapala college and they open their laptop and then they request for a permission the JMJ college to permit them to operate the GC, which is located in the gas chromatography located in what is called JMJ college Tenali. The concerned head of the department gives the virtual permission so that the student can start working from Rapala, so he can operate operate simply by seeing the health of the GC, what is the temperature of the column, and then what is the gas flow rate, and the sample injection. Everything can be done by the student simply by sitting at a Rapala. Means how is it possible through his gas chromatography of Tenali, JMJ College Tenali, through internet? It is going to happen in future. So that is one which we are going to discuss in detail. So in this case, IoT devices and sensors, whatever are there, they must engage with the real-time data collection. Real-time data collection means what? What is the temperature of the column of the GC of Tenali must known to the Rapala guy immediately. That is a real-time data collection. Not only that, analysis. For example, okay, there is a sudden shoot up in the temperature. There must be a warning, red bulb. Warning must be there. So analysis and hands-on experiments, exploration, everything will be possible in future. Means what is going to happen here? The IoT is going to enable the laboratory equipment to monitor remotely and control the experiments, and then without your physical presence at a particular point, you must be able to operate it. So in this way, a person from Rapala can operate one of the instrument in JMJ college in future through IoT. Not only that, so in future, there is a possibility of the tailoring of the educational content. What is the meaning of the tailoring of the educational content? For example, a particular student is interested to work on particular feature of the HPLC, high performance liquid chromatography, present in the JMJ college. Okay, and what happened? The JMJ college closes by 5 o'clock. But his examination is scheduled within 2 days. The next 2 days are holidays. Now, how can he perform the experiment? Because without performing experiment by himself, he cannot do well in the final examination. In such case, the head of the chemistry is going to permit that particular student to operate that particular instrument via IoT, means tailored educational content. So based on the requirement of the particular student, we are giving permission to operate the instruments and as well as the educational content, whatever is there. So in this way, IoT is going to play a vital role in the chemistry education to foster the innovation, collaboration, deeper understanding, and all these are possible. Now, okay, not only this IoT is going to play a vital role in the environmental chemical monitoring. What is this environmental chemical monitoring? So environmental chemical monitoring means there is one industry. From that industry, okay, let us say that there is a release of some hazardous substance. Let's take one example like a Bhopal gas tragedy. Every one of us knows that Bhopal gas tragedy happened because of release of a gas, a very hazardous gas, where no one given the indication to the nearby people. No caution was given. If some caution was given, probably there was a possibility to evacuate the population around that what is called Bhopal industry. What happened? Okay, for so many hours, no one has given for the release of that cyano gas. Such hazardous substance leakage is there. In those days, a particular human being or a chemist has to observe and they have to monitor continuously. They have to report it. Nowadays, not required. If there is a spill of a chemical, if there is a release of a hazardous substance, or there is a release of a harmful pollutant, immediately the concerned sensor is going to make an alarm. Whenever such an alarm is there, automatically the nearby government or the people will be warned and they will be made vacant from that place, and if necessary, we can clean and protect the air. So, how is it possible? A human being cannot continuously observe whether there is a leakage of a chemical, okay, with out of the so many thousands of meters of pipe. If so many thousand meters of the pipe is there, where from there is a leakage? How can we know? That to constant correction of the data is not possible by a human being. But a constant collection of the data, whether there is a leakage of the what is called any chemical, spillover of the chemical, or a rise of the temperature, or the rise of the pressure, or pressure changes, all those can be done with the help of sensors and proper devices which are going to connect all these through internet. So the IoT based sensor networks, they are going to help not only for the chemical monitoring system, for irrigation system, pipelines, reservoirs, weather stations, ocean applications, etc., etc. At all these places, they are going to be helpful to monitor different physical parameters. What are those? The monitoring point may be, parameter may be contaminant. As I said, it may be temperature, humidity, water level, leakage, what it may be, everything can be monitored very continuously. Now, before in continuing, first of all, let me know from any one of you, am I audible, first of all?
Yes, audible.
Okay, right. My slides are changing now?
Yes, sir.
Yes. Okay, are you comfortable with my pace of delivery?
Yes.
Okay, am I too slow? Am I wasting your time?
No, sir. Comfortable, sir.
Okay, then fine. Okay, if you feel any inconvenience, let me know that. Accordingly, I will tune myself. Thank you.
Okay, okay.
Now, here we have seen how IoT is going to be helpful in pharma or industry, pharmaceutical industry, or general chemical industry, in the case of analytical chemistry. And then we are going to discuss about, can we incorporate the principles of green chemistry into analytical chemistry? Yes, it is possible. How can we incorporate green chemistry principle into analytical chemistry? What is green chemistry principles? 12 principles are there. What are the 12 principles? One of the principle is minimization of the waste. Can we minimize the waste? Yes, we can minimize the waste. How can we minimize the waste? Okay, when we take any analytical procedure, for example, let's take either HPLC or GC or UPLC, that is UPLC, that is ultra performance liquid chromatography. In all these cases, if you want to propose an analytical method, there will be two steps. One is method development. The second one is method validation as per the existing ICH guidelines. Whenever we take method development, in that method development, we are going for the optimization of the different parameters. Whenever we take the optimization of the different parameters, there will be wastage of the so much chemical. In such cases, if you are able to use a software that is QBD, that is a quality by design, automatically it is giving the optimum operational conditions. It is giving what? Optimum operational conditions where it is helpful for the minimization of the waste. And no need to do many iterations. No need to waste our own energy. No need to waste the human resources. No need to waste the chemicals by doing the so many runs. In HPLC or GC or UPLC, we do so many runs. So whenever we do each run, if I say the run time is 20 minutes, if it is increased to 50 minutes, the run time increase means automatically the mobile phase wastage is more. So all of them can be reduced by one technique, that is QBD. So what we are able to do that green chemistry principle is minimization of the material or energy or wastage. Yes, all these can be achieved in analytical chemistry with the help of the QBD. But the problem, let us say that QBD, the quality by design software, is not available immediately in our college. Then what you are going to do, if it is available with your sister concerned organization through internet, you can avail that facility. So ultimately what we are going to do, you are able to propose an eco-friendly analytical method and a safe method, real-time method. All these are possible with the help of this IoT. And in this case, the intelligent strategies will be there, and a cloud-based technology will be going to helpful for us. And this one is useful to monitor not only the real-time data but also on-site data. Means whether you are physically here or away from that, both are possible. As we said repetitively, in our case, we call them as chemical sensors. In other cases, they may use one more word. It may be the related devices. So we are going to use all of them to monitor the environmental parameters also. So here we can say that they are having the synergetic effect. What is the meaning of the synergetic effect? If 1 plus 1 is added, we say 2. No, sometimes if you add 1 plus 1, it may become 4, ultimate result. So, more than the expected output increase is there, that is called synergetic effect. Such a synergetic effect is possible by the usage of these chemical sensors. So, when we take this IoT, this one is useful for both on-site as well as off-site monitoring. That too, for the analysis can be done very accurately for many chemical analytes. That too, for a low cost with the usage of very low power, wireless communication, and where we can use small and reliable devices. What are these? Let's discuss a little bit. In olden days, there was a need to connect the sensors to the central monitoring system through wires. That's why the operator used to be the nearby proximity to the instruments. But nowadays, we are having a beautiful technology, that is 5G technology. Even earlier, wireless communication was possible. Wireless communication was possible only in the case of few fields like military or what is called national disaster mitigation system, or what is called a fire department, or the police department. Very few members were having the wireless connections because that one is very costly, and that too the accuracy of the information was very less. Means the security of the information was also very less in those days. But 5G is available, which made this a wireless communication. The ceaseless wireless communication now it is possible. So IoT became popular nowadays because of this 5G system. And the devices, whatever we are using, simply nowadays, okay, you can see that nowadays the farmers are switching on or switching off their water motors in their agricultural fields simply by sitting at their home itself. How? They are operating from their mobile. So there is a small device. So in this way, low cost, low power, wireless communication, that too integrate with small and reliable devices. Just like in the social IoT, industrial IoT is also nowadays possible. As we said, okay, we have discussed IoT, how it is going to be useful. Now let's strike onto the green manufacturing industry. First one is predictive maintenance. What is the predictive maintenance? Then earlier we have discussed what is predictive maintenance. Always the instruments are embedded, are connected with the sensors, so that continuous data is collected and monitored and analyzed, so that we can predict the wear or tear or shutdown of a particular equipment. Not only that, we can predict or detect the errors also. And then we can monitor the production status, and we can also go through the product output. So from all of these, we can be able to identify if any problem is there in the operation. Is there any problem in the process? If there is so, what might be the root cause? We can do the prediction. So based on the prediction, immediately the concerned management can be done. Not only that, this is also useful to achieve transparency. What is the meaning of the transparency? If you take any industry, whether you are maintaining the quality of the product or not, it must be the particular industry must be able to show to all the vendors. For example, if you take the pharmaceutical industries in Hyderabad, so they must get approval from the Federal Bureau of America. So when we take that Federal Bureau of America for monitoring the quality, they go through all the records. If it is done by human being, so there is a possibility of manipulation. But in this case, all the data is collected by sensors and stored in cloud, not stored in the data books of the industry. So there is no possibility of the manipulation of the records. So such a transparency is very much possible. And then here, not only that, okay, if any uncertainty is there, we must be able to explain it. And there are smart sensors are there. And then what is the purpose of this smart sensors means here they will be helping not only to gather the data, okay, they are able to process the data. So here 2 points are there. Gathering the data is there and processing of the data. So gathering the data is done by simply a sensor, but processing the data has to be supported by a suitable learning algorithm or artificial intelligence program, so that we must be able to achieve the predictive manufacturing capabilities. So in this case, yes, we are able to gather the data, and the product design development can be done, and then life cycle assessment can be done, and the wastage production can be reduced, and then the reuse capability of the industry is going to increase. So in this way, the IoT is going to help a manufacturing industry to turn into a green manufacturing industry. Not only the prediction, even for the enhancements of the process control. What is the meaning of the enhancement of the process control? For example, if I say the pH or temperature has to be maintained at a particular value, simply by noting the data and then processing the data is not enough. You must be able to manipulate the concerned, what is called the equipment also. If you are able to do that, then only you can process, you can control the process. So here, sensing and collecting the data, and then optimizing the product formation, all these are possible with the help of the IoT. Now, whenever we take this IoT concept, not only you can control it, this one is also useful to override the devices and override the machines. What is the meaning of the overriding the device and overriding the machines means? Okay, if a particular device is a machine is working at its own working style, it manipulates it so that the production flow can be improved. So for all this purpose, the RFID technology is going to help us, which is going to integrate all the connections between among various devices whatever are there, and ultimately help us what is called the worker who is working in the industry. They will be best assisted by this RFID technology, so that waste management techniques can be adopted. Okay, so here this IoT is also going to help us to attain the SDGs. Nowadays, the buzzword is SDGs. What are SDGs? Sustainable Development Goals. What are these Sustainable Development Goals? Okay, if you look at the colleges or universities are given ranking based on the SDG. Sustainable Development Goal, based on the Sustainable Development Goals, you are getting what is called marks based on your SDG score. Some of the organizations are getting the research funds or general funds. So what are these SDGs at all? So all of us aware that the United Nations in 2015 September, they have adopted a resolution regarding sustainable development, and then when we take this sustainable development, it has given one agenda to be achieved by 2030, which is having 17 SDGs are there, which are called 17 SDG means Sustainable Development Goals. Number of Sustainable Development Goals are 17 Sustainable Development Goals. Of course, each and every goal is associated with the target to be achieved, and these 17 universal goals are having about 169 specific targets are there, and they are associated with the indicators. So when we take these SDGs, this is Sustainable Development Goals, whatever are there, so most of them are related with the waste management of the chemicals. So from this, what we can say that so if we are able to use properly the IoT, we are able to get the sustainable development. So the green chemistry is going to help us to achieve the SDGs, that is sustainable development goals. So when we take this IoTs, already we are aware that these IoTs are embedded. Embedded means associated with the sensor, software, step motors, etc., etc. And here the software in our common language, or simply we can say that open source contribution is going to help us a lot. Means it may be in terms of software or hardware. So if such open source contribution is there, that one is useful for the democratization of the production. What is the meaning of democratization of the production? If a production of a particular item is there, if it is accessible to all the people all over the world, then we call it as democratization of the production. And governance, knowledge exchange, all is possible if some open source contributions are there. Yes, at present, such open source and popular platforms are available. Those are Arduino and Raspberry Pi. These are the two systems which are very much used by our chemists. And when we take this Arduino, this was developed in Italy in 2005. And what is the advantage of that one means because of its very low cost, and then we can operate on different our platforms. You have whether we are using Windows in our laptop, whether it is iPhone, Mac, or if you are using open software like Linux, also operating system, also we can use it, and it is very simple to program on it. Similarly, if you take a Raspberry Pi, so this one is also another one, and one more development in this IoT is ESP8266, which is nothing but a low cost Wi-Fi microcontroller, and ESP32. Actually, this is a series of low cost, low power system on chip microcontroller. So in this way, the contribution from different ends are making the IoT into usage. Okay, as we said, the open platform like Arduino, which was released in 2005, and Raspberry Pi in 2013, how they are going to convert the IoT market. So you can see that this Arduino, the primary analytical application, we were able to get just before 2013, and then before 2014 itself, the term IoT, Internet of Things, was cited first time, and in 2014 means just after 2013 Raspberry Pi release, the primary analytical application of it was done, and in 2015 a primary analytical application through Bluetooth was happened, and then already we have seen this low cost Wi-Fi microcontroller, that is ESP8266. First analytical application was achieved in 2018, and similarly ESP32 low cost, low power system of chip microcontroller. Okay, its primary analytical application was observed by 2019. So likewise, we can say that the timeline of this IoT contribution to the chemistry is happening progressively from time to time. So though we are able to achieve a little bit, still a lot to achieve to in the case of IoT. Okay, and hope that definitely this 5G technology is going to make it soon possible. And along with that, as I said that open platforms for Arduino and Raspberry Pi, and here if you are able to get sound knowledge in a program like Python, so that is going to help us even to bring the AI into this fold, so that further fruitful output can be observed. So in this way we can discuss about the application of IoT in green chemistry. Okay, before going to discuss about AML in green chemistry, can I know from the organizers what is the time left over to me?
20 minutes, sir.
Yeah. So okay. Now it is 4:25.
Yes,
As
sir.
madam
Yes.
said, yeah, 4:25. So time left over for me is 25 minutes.
Okay.
Okay, 20 minutes. So let's have just a break. Madam, tell me.
20 or 25 minutes, sir.
Okay. No, don't worry. Okay, I will try to finish it within 15 minutes. I can understand.
Okay.
This Saturday is weekend. I do not want
Okay,
to bother
okay.
participants much. Okay.
Okay, sir. No problem. Carry on, sir.
Yeah. Okay. The rate at which I am delivering the goods, is it fine? Madam?
What, sir?
The rate at which I am delivering the lecture, is it fine?
Yes, sir. Yes, sir. Yes, sir.
Is it too speed or too slow or wasting
No, no,
your time?
It's
Alright,
comfortable, sir. Comfortable.
then fine. Okay. Dear participants, don't worry. Okay. Though madam is saying that 20 minutes, okay, I will try to finish within 15 minutes. Okay, right. Okay, because this is Saturday. That's why. Otherwise, the lecture actually it is more than 1 hour. That's different. Okay, how this AML is going to helpful for us in green chemistry? Let's discuss a little bit. Every one of us know that the father of chemistry is nothing but Anastas. And then if you look at one of the rising star of the industry is Dr. Yuan Yo, and he worked along with this father of green chemistry. So the rising star Yuan Wo, who worked along with the father of green chemistry, he has given one beautiful statement. What is the statement given by him? He says that I believe that artificial intelligence shows greater potential in reducing the energy consumption and environmental footprints for the chemical industry. So, in this way, the industry person was able to anticipate how this AI is going to merge with green chemistry. If you look at the AI and green chemistry, if you look at the AI and green chemistry, though it is taking a little bit advanced nowadays, you can find some of the exclusive seminars or conferences on them. Recently, ACS, American Chemical Society, the American Chemical Society has conducted one conference with a main theme, AI enabled green chemistry. The main theme of ACS, that is American Chemical Society, which was conducted, I think, recently in the June, like that. Okay, June 2024. So that is AI-enabled green chemistry. So nowadays, few scientists or chemists started working on the interface between AI and chemistry, and slowly the research output and as well as their citations and their applications have been increasing. Of course, the era started in 2015 and it is increasing not geometrically, it is increasing exponentially day by day. So before going to discuss about how these are going to be helpful, just quickly let's look at the common words which we use here. That is AI, artificial intelligence, ML, machine learning, DL, deep learning. What is this artificial intelligence? Artificial intelligence means if you take a computer, if it is able to get the ability to perform the tasks which are commonly associated with the intelligent beings. Who are the intelligent beings? Human beings. So, just like human beings, if a computer is able to perform, that is called artificial intelligence. Machine learning. So, when we take this machine learning, what we do, we are going to make the machine to learn. You are going to make the machine to learn. So, how a machine is able to learn? With the help of few algorithms. So we give some examples to the machine. With the help of the algorithm, the machine will be able to understand and it is able to experience. And whenever new data is given to that based on the old data and information, it is able to give appropriate proper information. So, in the case of the machine learning, the algorithm is going to help the machine to understand the feed in terms of the few examples given by human beings to the machine, so that the machine is able to predict the data, predict the output based on the new data given by us. The last one is nothing but the deep learning. We can say this deep learning is nothing but the part of the machine learning, which is focusing mainly on the learning data and as successive layers of the increasingly meaningful representations. Of course, you can say AI is a superset, where ML of subset of it, and then further subset of it is nothing but the deep learning. When we take this AI technology, it is having so many applications in drug discovery. But of course, though it is directly related with our chemistry, but the drug discovery doesn't restrict it to the molecule design, but also it involves in the clinical trials, etc. That's why I'm not going to discuss much on it. So at present, we confine ourselves to how AI is useful to optimize any chemical reaction. So when we take any chemical reaction, first of all, one must have what are the reaction conditions to happen the reaction. What must be the temperature? What must be the time? Okay, what must be the pressure? So reactions conditions are required so that the reaction can be executed. After the execution of the reaction, we get a product. The so obtained product, whatever is there, we have to detect and analyze it. What is the meaning of this, both in terms of the qualitative detection as well as the quantitative estimation? So, based on the inputs of these reaction condition recommendations and product detection and analysis, we will be able to make a model. So, here a number of reactions are done. So, number of reaction conditions, the concerned reaction product parameters will be there. That data will be useful as to refine the required updated model. So that model is going to help us to predict the future product output based on the new set of the reaction conditions. So where this AI is going to help us in the chemical manufacturing, we can say that to optimize the yield and to predict the product grade, and then okay, if you want to produce or if you want to develop the new product also, and then how the demand for the product is going to be changed in future to forecast that one, and then any safety measurement has to be improved on the site. That also can be done with the case of the AI. So when we take this AI, as we said that this one is useful for the optimization of the reactions. How this is going to be helpful? Okay, in the optimization of the chemical reaction, how this AI is going to be useful? What are the advantages? The first one is it is useful to improve or enhance the effectiveness. Improve or enhance the effectiveness. So in this case, we are going to take the help of the AI. The artificial intelligence is going to optimize. The optimization is going to help us to decrease the number of the cycle times, and it is also help to promote the efficiency and to increase the productive capacity. That is enhanced effectiveness. The next one is the cost of the production, that is expenditure can be lowered. When we take this artificial intelligence, that one is going to reduce the expenditure indirectly. How? That one is going to help to reduce the energy consumption. So whatever the terms we are discussing, ultimately one of the 12 principles of the green chemistry only. So the energy consumption is reduced. Not only that, the utilization of the raw material is also reduced. The waste generation is also reduced. All of them is possible because of the AI, which is capable of optimizing the process parameters. How is it possible? Nowadays it is possible with the help of, even in our cases, when we are using DOE. What is this DOE? Just I said that earlier, QBD, quality by design. In the case of the analytical method development as well as its validation, that QBD is a very good help is there to raise the quality, to reduce to reduce the efforts of the analytical chemists. In a similar way, for an organic chemist, the DOE, the design of experiments, is going to help them to optimize the process parameters so that energy consumption, raw material utilization, waste generation, everything can be reduced. And then high capacity. So in this case, okay, as the already AI has done the optimization, we are able to give a guarantee on the constant product quality. When it is possible, we are able to lower the errors or any changes or variances. So whenever we are able to do all of them, we can say that tracking and regulating the process is very easy, and hence automatically the capacity is improved. And predictive management and increased security and making decision based on the data, and then environmental effect reducing, all of them is also possible, just like whatever we have discussed. Okay, now here let's look at some of the fields where this AI at present is helping us. One of that one is detection of the molecular properties. What is the detection of the molecular properties? Okay, when in olden days, if any particular chemical is produced, it's the molecular properties, whatever are there, one has to measure, one has to determine by themselves. But nowadays, AI is going to help us to predict their molecular properties, and it is also helpful to classify those molecules based on their properties. Means Okay, the AI is going to help us to predict a particular chemical is toxic or not. Is it going to be soluble in a particular solvent or not, or which solvent can be used, means prediction of the solvent for its solubility, and whether a particular reaction is going to happen or not. Means in olden days we have to look into what is the delta G value, is it plus or minus, okay, what is the value plus or minus, what is the value, okay, it is the endothermic or exothermic, how much temperature has to be increased, everything has to be done from our side. But nowadays this AI algorithms are going to help us even to predict the reactivity of those molecules. So this is also going to be helpful. And the next one is the designing of a molecule. So when we take this is just similar to that of our cheminformatics or bioinformatics. What happens in the case of the cheminformatics or bioinformatics? So based on my required properties, okay, the constant CRO, that is a chemical CRO company, whatever is there, chemical reaction synthesizing company is there, CRO, they have to prepare and produce the new molecule. So that means based on my requirements, the molecule has to be designed or it has to be synthesized. That is also possible with the help of the AI. The discoveries of the drugs. The discovery of the drugs means already we are aware that we synthesize the molecule, but to release the molecule into the market in the form of a drug, it has to undergo 4 stages of the clinical trials, that is phase 1, phase 2, phase 3, phase 4, and which may take 12 to 16 years, where you have to spend lot of time, lot of money, lot of efforts, lot of chemicals, and a lot of species also, where so many regulatory authorities are making restrictions on the clinical trials. In such case, whether the molecule prepared by me is going to work against a specific target or not, how we are doing, how we are publishing our works with the help of molecular docking studies. So, in a similar way, here in the case of molecular docking studies, what we are doing, we are giving our chemical molecular structure from our chemistry data, whatever is there, and that based on the chemical molecule structure, it is going to predict, it is going to act on a particular target of a molecule, target of a cell or not. Means receptor is going to be attacked or not. So in a similar way, similar to our molecular docking, this AI is going to also helpful. Retrosynthesis. Nowadays, most of our work is based on the retrosynthesis pathway only. So based on the final molecule what we require, we cut down and we can predict what is the starting molecule. So in such cases, what is going to happen? The if you are able to do the proper synthetic mechanism, if you are able to give a proper scheme, definitely you can get the required product. But that retrosynthesis requires a lot of knowledge. And sometimes you may have one doubt whether I did correct or not. Counter checking is also required. In such cases, the retrosynthesis scheme can be given by this artificial intelligence also. Not only that, here the predictive analysis. What is this predictive analysis? Okay, the patterns. Already some patterns are there. For example, some chemical spectra is there. The chemical spectra, from that chemical spectra, it will be able to identify what is called functional groups based on the peak position, and it is able to say what is the amount pressure based on the intensity of the peak.
Sir, your internet problem, sir. Your net problem, sir. Check your connection, sir. Sir? Sir? Okay, sir. Okay. Hello, sir? Hello, sir?
Out of date.
It's okay, sir. I think your net problem, sir.
Yeah, maybe net also.
Sir? Okay, sir. Not audible, sir. Not audible. Please unmute, sir.
Yeah, sorry. Okay, I lost the connection.
Okay.
Yeah. So earlier we have seen that the patterns are going to helpful for us with the help of the AI. How it is going to happen means now let us take a particular case. Let us say that okay, we have prepared the samples, and whenever we prepare the samples, we are going to analyze them. Let us say that the instrument used in this particular case is nothing but a spectrometer, and then when I have taken a number of samples, for each and every sample I will be getting different spectra. So I was able to gather a number of spectra which I am going to maintain in the form of a database. So now I am going to take the machine learning module so that it is going to classify, the algorithm is going to classify all of them into model library, and that model library, whatever is going to helpful for us ultimately for the ancillary spectral data. Means what? Okay, whatever we have seen, that is the forward path, and there is another one. Let me say that I have taken the unknown material. For the unknown material also, was fed to the spectrometer, and then I got the spectrum, and the spectrum is fed to the computer, and based on the model library, whatever is there, the model that whatever is there, ultimately you are going to get the model results. Means you are able to predict what is called the results based on the previous data. So ultimately, in this case, as we have seen, though I am using that AI, artificial intelligence is the superset, and machine learning is the subset, and deep learning is the further subset. So though I say it is ML, there is machine learning application, nothing but AI application only, that one. So in this case, we are using a spectral database, which we are able to, this spectral database means we are storing the data of the spectra which are obtained from a number of samples which were earlier analyzed, and we know their composition also. And then Here we are using a mission module. So in this case, as I said, we are going to select a proper algorithm and we are going to configure its parameters and we are going to build a model which is built, that model is built by applying the algorithm based on the whatever the data which is taken from the database. Okay, so with the help of the algorithm, okay, we are able to make a model library. This model library is storing the previously built different models in it. Then coming to the picture of this graphical user interface. In this case, we are getting the output from the spectrometer in the form of a graph. Spectrum means nothing but a graph. So this graph is the feed given here. The data is not the data. It's a spectrum is given. Of course, from the spectrum, the data can be taken. So the data from the spectrometer for the unknown compound, whatever is there, is retrieved with the help of this model library. The suitable model can be given. So in this way, it is going to help us. Of course, where this one can be used or benefits are there means the first responders. Okay, who are the first responders? First responders means, for example, okay, nowadays our house is also full of so many poisonous chemicals. Okay, whatever the sprays we use and whatever the plastics we are using. So in our house also, so many chemicals are going to be okay. If you feel that you are in your house because of, if you want to know, you can capture that gas and then analyze based on the data. Yes, the first responder, you can get the information. Unlabeled medicine. So there is a medicine, but you do not know what is it exactly. Yes, you can label them properly. And hazardous materials, all of them. And then law enforcement and forensics. So law enforcement and forensics means, for example, a particular drug is seized from a particular drug peddler. In such case, identifying particular drug is done with the help of this one. And the pharmaceutical industry and the process analytical technologies in the environment. Environment is having so many applications which were already discussed here. But though we discussed a lot, the point we have to take into consideration is nothing but the challenges and the limitations. What are those? Yes, we discussed, but understanding the technologies, but shortage of the artificial intelligence skill in the workforce, lack of the quality data, and issue of the trust and transparency, and uncertainty regarding the return on investment. Yes, we invest, whether we get it back or not. Understanding the technology is also difficult. Skilled person is also not available. And data is there, but quality data you have to generate. All these are the challenges. I am not going to discuss them. And the disadvantages also there. Lack of explainability, data bias, limited generation, and a high competition requirement, ethical concerns, integration challenges, human expertise and judgment. All these issues are also there. Actually, I am not discussing at them. And only I talk few words about future prospects of AI in chemistry. This one is going to definitely help us, what is called accelerated drug discovery and precision medicine, green chemistry, material design and discovery, automation and robotics, and the integration of the big data. So we can expect the application of the AI in these chemistry different fields. Okay, as time is not permitting me, today I stop here. Whenever time permits, let's discuss in detail about actually artificial intelligence. There are few applications are there and machine learning also is there, but time is not permitting me. That's why I'm stopping here. I hope that next time we can discuss. Thank you. Madam, that's all from my side.
Okay, sir. Thank you, sir. The time already over, sir. That's why. Hurry up. Thank you, sir. Now let us start our program with the validity session. We are pleased to invite Dr. Sister Shaini KP, Principal of JMJ College for Women Autonomous Tenali, to deliver the validity remarks of 5-day international webinar.
Thank you, Dr. Nirmala Jyoti. Good evening, everyone. It is with great pleasure that I address you. Am I audible?
Yes, sister.
It is with great pleasure that I address you today to deliver the valedictory address for our international Webinar-cum-FDP on innovative approaches in green chemistry for addressing emerging challenges in chemical and allied sciences, held from September 10th to 14, 2024. As we draw this enlightening 5-day event to a close, I am filled with a profound sense of gratitude and admiration for all those who have contributed to its success. This webinar has truly been a remarkable platform for connecting academics, sharing insights, and exploring groundbreaking approaches in the field of green chemistry. Firstly, a special thanks to Dr. K. Nirmala Jyoti, the convener and head of the Department of Chemistry, for her outstanding efforts in organizing this webinar. I also appreciate Dr. V. Sumalada, Mrs. M. Shakina Kumari, Ms. G. Esther Rani, and all faculty members for their support. I wholeheartedly thank Dr. Sister Amul Mary, Mr. Yashwant Dutt for their technical expertise ensuring the smooth execution of this event. A special note of gratitude to all our esteemed speakers for their insightful presentations and engaging discussions. Your contribution have significantly enriched our understanding of green chemistry and its potential to address the emerging challenges in chemical and allied sciences. I extend my sincere thanks to all the participants who joined us from across the country and beyond. Your active involvement and enthusiasm have made this webinar a truly collaborative and enriching experience. As we conclude this event, let us take with us the valuable knowledge and ideas exchanged over these days. May we all continue to build on the momentum created here, advancing our research and practices in green chemistry to meet the challenges of tomorrow. Once again, I thank you all for your contributions and participation and making this webinar a successful one. Wishing all continued success and inspiration in your future endeavors. Thank you all once again.
Thank you, sister, for your valuable remarks of 5-day international webinar. Now I am going to deliver the brief summary of the 5-day international webinar. Respected speakers and my dear participants, I would now like to take this opportunity to express my deepest gratitude to all those who made this webinar a grand success. A special thanks to our distinguished speakers for their valuable insights, to the participants for their active engagement. Over the past 5 days, we have covered several cutting-edge topics under the theme of innovative approaches in green chemistry for addressing emerging challenges in chemical and allied sciences. The sessions covered various aspects, providing valuable insights and discussions for all participants. It is with great honor that we conclude this event with a heartfelt appreciation for our distinguished speakers. First today our keynote speaker, Dr. Srinivasarao Amarneni, CSCI, CChem, FRSC, extensive knowledge demonstrated through his numerous prestigious fellowships and his enlightening address on green analytical chemistry approaches on environmental analysis and sustainable development, has provided invaluable insights into sustainable practices and environmental responsibility. His expertise and pioneering work in chemistry have inspired us to adopt greener solutions for a more sustainable future. On behalf of all participants, we express our sincere gratitude for sharing your expertise with us. We are deeply grateful to Dr. Akhilesh Kumar, international speaker, Professor Bar, a special appointment at Eva Women's University, Seoul, South Korea, for his insightful presentation during the second session. His lecture on metal oxygen intermediates in dioxygen activation and formation chemistry has broadened our understanding of this intricate and crucial area of research. Dr. Kumar's expertise and truly inspiring. We sincerely thank him for sharing his profound knowledge with us and enriching our event with his international perspective. On the second day of our event, we had the privilege of hosting Dr. Venkateswara Surisetti from international speaker, a senior scientist and a principal investigator specializing in manufacturing technology and senior engineering specialist from the United States of America. Dr. Surisetti delivered an insightful lecture on chemical and process industrial safety in Telugu states, India. His expertise and valuable perspectives provided us with a deeper understanding of safety measures and best practices in the chemical and process industries. We extend our sincere gratitude to Dr. Surisetti for his contribution and to all participants for their engagement and enthusiasm throughout the session. On the third day of our event, on behalf of everyone, I would like to extend our sincere thanks to Dr. Amit Rajput, Assistant Professor at J.C. Bose University, Faridabad, Haryana, for his engaging and insightful talk on metal coordinated ligands, radical species. His deep understanding of this fascinating topic has enriched our knowledge and sparked new avenues of thought. We are truly grateful for his valuable time and contribution, which has significantly enhanced the quality of this session. Thank you, sir, Dr. Rajput, sir, for sharing your expertise with us. On the fourth day of our international event, led by our esteemed speaker, Dr. Jeremiah Kiran Billa from the Department of Advanced Technologies at Alcorn State University, Lormont, USA, has truly been enlightening. Dr. Billa's talk on radiological implication of soils collected in the vicinity of a coal ash pond has not only broadened our understanding of environmental hazards but also underscored the critical needed for sustainable practices in addressing industrial waste and its aftermath. His research and findings on the radiological effects on soil quality due to coal ash disposal highlight the ever-pressing issue of environmental stewardship and the need for scientific intervention to mitigate long-term consequences. His work stands as a beacon of what can be achieved when science, innovation, and sustainability are seamlessly integrated. Last but not least, sir already with us, today's speaker, I would like to express our sincere thanks to Dr. R. Venkatnath, Professor and Co-Chair of the Board of Studies in Chemistry at Geetham University, Bangalore campus, for delivering an insightful talk on artificial intelligence and Internet of Things poster, green chemistry. From the role of artificial intelligence in fostering sustainable practices to the interdisciplinary collaboration that is needed to combat global challenges, this session has offered a platform for meaningful discussions and knowledge sharing. Dr. Nath's presentation has provided us with a fresh perspective on how cutting-edge technologies like AI, IoT are revolutionizing green chemistry, driving sustainability, and enabling more efficient practices in the chemical sciences. His expertise and vision have left us inspired to explore the endless possibilities in the transformative field. We are truly grateful to Dr. Nath for sharing his knowledge and contributing to the success of today's session. Thank you, sir. Thank you once again. My special thanks to organizing committee for their tireless efforts behind the scenes. I would also like to extend a heartfelt thanks to our principal and the management of JMJ College for Women, Tenali, for their continued support. I also want to thank everyone who has participated and contributed to making this event a meaningful experience. With this, we conclude the valedictory session of our international webinar. Thank you all for your participation, and we hope to see you in future events. As we close this event, let us remember that the pursuit of knowledge and innovation does not end here. This webinar has opened the door to new possibilities, and we look forward to seeing the impact of these discussions on scientific community and beyond. So, thanks to all. Have a wonderful evening for the success of this 5-day international webinar. Thanks to for all the participants. Sir Venkatanath garu. Yes.
Thank you, madam. Thank you.
Thank you, sir. చాలా షేర్ చేసుకున్నారు మాతో మీకు టైం ఇవ్వలేకపోయాం సారీ సార్
No. Okay, let's meet again. Okay, thank you.
ఇంకొకసారి ఇస్తాం సార్ టైం మీకు థ్యాంక్ యూ సార్ థ్యాంక్ యూ సార్ బాయ్
Good evening, everyone. This is